Hello everyone, my name is Sivanjali. Today we are going to discuss about introduction to stacks. In this particular topic, we are going to cover introduction to stacks, properties of stacks and applications of stacks. Introduction. The linear data structure, linked list and arrays allows us to insert and delete elements at any place in the list, at the beginning, at the end or in the middle. A stack is a linear data structure in which insertion and deletion of elements takes place at the same end. This end is often called as top of the stack. Stacks as an abstract data type. Stack can also be defined as abstract data type. A stack of elements of any particular type is finite sequence of elements of the type together. Stack follows the last in first out principle or first in last out principle, meaning the last element added to the stack is first to be removed or the first element added to the stack is last to be removed. If we see in this particular diagram, the maximum size of the stack is 5. The first element added to the stack is item 1 and the second element is item 2. We can add the elements up to this maximum size. After that, we can no more add the elements. If we want to delete the item 1, we want to delete item 2 first and then item 1, which means the last entered element should be removed first and the first entered element should be removed last. Here are some key operations of stack: push, pop, is full, is empty and top. Here comes the push. The process of adding new element to the top of the stack is called push. Pushing an element is nothing but just adding an element. If we see this particular diagram, the top of the element is D. After inserting C, B and A, the stack reaches the maximum size and we can no more add the elements. If we see in this particular element, in particular stack, after adding the elements, which is nothing but after pushing the elements, the maximum size has reached and the top of the element is A. If we want to delete E, which is first inserted in this stack, we want to delete A, B, C, D and then E, which follows last in first out principle. Here it means the last entered element is A, which is removed first. Here comes the pop. The process of deleting an element from the top of the stack is called as pop. The operations deletion takes place from the top. If we see this particular diagram, the plus is the topmost element and here it is also called as the top element of this stack. After deleting plus, the top comes to 5 after decrement of 1. And if we see in this particular diagram, the top is D. After deleting D, E, there will be no more elements and we can't delete any elements. Top. Top is a function that returns the top of the element of the stack. Is empty. This particular operation returns true if the stack is empty, else returns false. Is full. This operation returns true if the stack is full, else it returns false. Algorithm for push. Before pushing an element to the stack, we check whether the stack is full or not. If the stack is full, the top reaches the maximum size, then the stack overflows. We can't insert any element. Otherwise, we can increment the top value by 1, that is top plus plus, and the new value of the stack is inserted at the top. The elements can be pushed into the stack till we reach the capacity of the stack. That is, if we see this particular diagram, the capacity of the stack is 4. After inserting 3, we contain one more space to insert the another element. After inserting the 4, we can no more insert any elements. Algorithm for pop. Before popping the element from the stack, we check if the stack is empty. If it is empty, then top is var is equal to -1. Then stack underflows, which means we can no more delete an element because the stack is empty. We can not remove any elements from the stack. Otherwise, we store the value of top and we can decrement the value of top by 1, that is top minus minus, and returns the stored top value. If we see here, the top is -1, which means the stack is empty. If we see here, the top is 5, which tells us the stack is full. Properties of stack. All insertions and deletions can occur only at the top of the stack. The elements that are removed from the stack in reverse order in which they are inserted. Only the elements can be pushed or popped from the stack at a time. Only one element can be pushed or popped from the stack at a time. It works in last in first out principle or first in last out principle, which we already discussed. Applications. If we comes to applications, we can use stack in processing function calls, memory management, string reversal, browser history navigation, evaluation of expressions, browser's back button. These are some applications of stack. If we take browser history navigation, the video in YouTube, the first we watched, will be in the last in the history. Here we have the quick recap of today's class. Introduction. Stack is a linear data structure in which insertion and deletion of elements takes place at the same end. This end is often called as top of the stack. Stack is an abstract data type which follows last in first out principle or first in last out principle. Key operations of stack. Push. The process of adding new element to the top of the stack is called push. The process of deleting an element from the top of the stack is called pop. Top returns the topmost element of the stack. Is empty returns true if the stack is empty, else false. Is full returns true if the stack is full, else false. Algorithm for push. Before pushing an element to the stack, we check whether the stack is full or not. If it is full, then the stack overflows. Otherwise, we will increase the top element by 1. Algorithm for pop. Before popping the element from the stack, we check if the stack is empty. If the stack is empty, then top is var equal to -1. Then the stack is underflows. We can remove no more elements. Otherwise, we will decrement the value of top by 1. Here are some properties. Here are the applications. Thank you.